Welcome to this video lectures. Here I will answer the question of this. That is how the output power of single phase full bridge inverter becomes 4 times the power handled by a single phase half bridge inverter. So this one is the circuit diagram of single phase full bridge inverter, and this one is the output waveform of this inverter, where we can see the output voltage is varying from plus Vs to minus Vs within the period of t. V output voltage is Vo is equal to Vs for t is greater than 0 to t by 2, and for t greater than t by 2 to t, it is minus Vs, that output voltage is minus Vs. Now the waveform expression for this waveform is summation n is equal to 1, 3, 5 to infinity. This is 4 Vs by n pi sine omega t. So unit will be in volts. So this is the equation 1. And we know power is I square R, or we can write as power as, putting the value of I is equal to V by R, it will be V square by R. Now just consider the resistance connected to it is 1 ohms. That is, load R is equal to 1 ohms. That means for fundamental load power, that is for N is equal to 1, I can write the expression of power as this square, that is 4 Vs by pi sine omega t square. Now, if I square it, I will get 16 Vs square by pi square sine square omega t. So this is equation 2. Now, we are discussing the single phase half bridge inverter circuits. Here, we can see the output waveform is varying from minus Vs by 2 to plus Vs by 2. That is, output voltage is Vs by 2 for t greater than 0 to t by 2. And output voltage is equal to minus Vs by 2 for t greater than t by 2 to t. Both are alternating current. So, for single phase half bridge inverter, output voltage expression is summation n is equal to 1, 3, 5 to infinity 2 Vs by n pi sine n omega t volt. So this is equation 3. Now again, we know the power is equal to I square R or V square by R. I am putting the value of R is equal to 1 ohms. So for fundamental load power expression, for the expression of the fundamental load power, it will be 2 Vs by pi sine omega t square. So this is, if I square it, I will get 4 Vs square by pi, 4 Vs square by pi square sine square omega t. So this is equation number 4. Now we have to prove the output power of this inverter is 4 times then the power handled by this inverter circuits. So dividing this equation 2 by equation 4, that is output power of the full bridge inverter by output power of the half bridge inverter is equal to 16 Va square by pi square sin square omega t by 4 Va square by pi square sin square omega t. So cancelling each other I am getting 4. So this proves that the output power of this, that is single phase full bridge inverter, is 4 times the power output of the single phase hub bridge inverter. Thank you for watching it.